Okay, so the phone that I was using as a camera has decided not to let me use the touchscreen. And so I restarted the phone. Hopefully it'll catch up. If it's still bugging out, I'll use my personal phone to do the recording of handwritten stuff. That, or I might just be able to look at the exam report and sort of point towards that. We'll work something out regarding that. But okay, so Year 12s have finished their exams. It's probably just going to be you and I think Shiloh in the Monday classes. So if there's anything in particular you want to look at for these classes, feel free, let me know. But otherwise, it seems like we're all at the stage where exam revision is the most effective thing anyway. So yeah, open to whatever, but if nothing else, we've got these, starting with question 3. Should probably check the Google form to make sure no one submitted anything. A little bit. Okay. Whole bunch of arches multiplied by a bunch of different equations. They're all more or less the same sort of equation. State the value of A, where A is located on H3, which would presumably be arch 3. There's a decent amount of background information, so
Is it 75?
yeah, 75 is going to be the way to go about that one. Or at least that'll be the answer. What was your method there?
I mean, the arch shoot ends at 70 and the arches are 5 meters apart from the base, so
Yeah,
at the base of the surf,
that's
75.
yeah, exactly right. Yeah, spotting that A is lower bound of the domain, and the spacing is always going to be 5 meters between endpoints. Precisely. Very good. Part B should be a very similar sort of vibe to it. How do we get from H2 to H3? How do we perfectly map that onto each other?
Shift in the negative horizontal direction by 35 units.
The negative by 35. So going from H2 to H3.
Oh, H2 to H3. Oh,
Yeah,
shift in the positive by 35 units.
that's it. Yeah, precisely. Okay. Part
Oh,
C. Find total area. Yeah.
maybe like just integrate the things, the arches, and subtract from 110 times 5.
Yeah, great idea. Absolutely. You don't necessarily need to do a top take bottom of like this y equals 5 and that whole thing. Yeah, if you find the integral of even just one of the arches and multiply it by 3, that'll also get you
Yeah.
there. Yeah, because you get your full rectangle and then subtract 3 copies of an arch. That'll be basically it. Yeah. Do you want to give that a shot, or are you happy enough with that's just the approach?
I mean, I'll do it anyways, I
Yeah,
guess.
easy. No, well done. Easy spot. Or fast spot, rather.
Is it 264 meters squared?
That's good. I like that you put the unit in there as well. Nice. 264 meters squared. Very good. Here we go. Second bridge. You've got this almost tangent looking thing, or I guess just a ramp attached to the top of it. State the gradient of the second bridge.
So it's up at 2 degrees.
Pi on 90, 2 degrees. What's that? Because 360.
I think you multiply a radian by 180 on
Oh,
pi.
yeah. 180 on pi. 180 divided by 90. Yeah, okay. Yeah, good point. 2 degrees.
Second bridge also has 3 arches below it. Wait, Chris, was there like for gradient, right? Is it a technique using tan theta?
There is, yeah, precisely. Tan theta is gradient.
Oh, okay,
And
so
yeah,
just be tan too.
if you have your calculator in degree mode, yeah. If you have it in radians mode, then you'll do it as pi over 90 as the angle.
Right. I mean, 0.035.
That's it. Yeah, 0.035. Tan of pi over 90 or tan of 2 degrees, whichever way you did that. Very good. Point P is on arch 5.
As a second bridge.
Two.
On the perpendicular P, connected two decimal places. Okay, so the derivative at some point on the curve needs to be equal to tan 2.
Yep.
Right.
Precisely. Just remember it's arch 5 now, so your function translations are going to be a bit different.
I mean, they're identical though to the old function.
Yeah, they're all going to be identical, so I guess even if you use the basic function, just be sure that when you get your x value, you need to shift it forward by a certain amount. It's like if you were to use the arch one. Actually, hang on. Yeah, does it start at... Oh, actually... Yeah, because arch 5 is... Oh, it is exactly the same spot as arch 2. Yeah, okay. Sorry, I thought it was even further beyond. Yeah, good point.
Yeah, I'm having some trouble with this one.
Yeah. How so? So what are you attempting so far that's gone a bit off?
Oh, actually, no, hold up. I think my calculator was in degrees mode.
Okay.
Let's try something again real quick. Okay. So I'm trying to find the derivative,
Yep.
and then I'm solving for which x, like I'm putting in the solve equation to tan 2 for x,
You're in degree mode?
radian.
Well, then it's tan pi over
Tan
90.
tan pi 90, yeah.
Yep. Okay. So yes, it'll be derivative of the arch function should be equal to tan pi over 90. Because tan pi over 90 is going to be the gradient of that line. They are tangent, which means they share that line. Oh, they share that gradient.
Yeah, I'm gonna see if I can get it.
Mhm.
Was exam 2 for methods today?
That was Thursday.
Oh,
So
so
yesterday.
they're
Yeah,
done.
they were on Wednesday, Thursday were the exams.
Right, okay, so they're done.
They're done.
That's
Yeah, done and dusted.
holy.
Yeah, it's fun to
I
think
got
about.
I think I got a general solution.
Yeah. Did you have a domain with your function?
So when I get the derivative function, should I put that into like another function but with a domain? Or you just
Well, it depends. So when you defined the initial like h2, perhaps, did you define it with the domain with it?
yeah.
Okay. So that means that when you did derivative of h2, you should also that should also be innately applied when you do derivative. Okay. General solution. I mean, you can try slap another domain on it and see if it helps. I would have expected the domain from your definition to pass through.
Okay. Does that have to be corrected 2 decimal places?
Let's find out.
Yeah, it does.
Yeah.
And I've just gotten the x values. I need to put that back in to h of x.
Yep. Yep.
That's a massive x value.
Massive X value.
Wait, okay, 54 is the
50,
x value. 54.36.
54.36 is the one you're looking for. Yeah.
Wait,
That's it.
hold on. I'll put it into h for the y.
Yep. Yep.
Uh, and then 4.99.
And then 4.99. Exactly. Yeah. That's precisely what you want to do. So if I pull up 3e, yeah. So derivative of h2 is equal to tan pi over 90 or tan 2. That's going to get the x value you suggested. Chuck it back in to get the y value, and then yeah, there's your point. Easy. So the fix there was that doing another domain on
When
top.
I got my derivative right, I had some like weird bracket on it. Like
Weird
not
bracket.
bracket. It was like sort of
Oh,
like a
yeah. No, I know what you mean. Because when you
you
have a
know.
yeah, when you put a domain on the initial function and then do derivative, it puts it in
Yeah.
a piecewise, I think.
Oh, okay.
Is that what you're saying? It's in a sort of
Yeah,
piecewise.
yeah. And then so then instead of when I was doing the solve right, I forgot to put the domain in.
Hmm.
I was just copying in the derivative instead of like I wasn't copy pasting. I was like trying to like type it.
Oh,
So
sure.
I forgot to chuck in the domain.
Yeah. Okay.
But then I copied that solve function and put a domain on afterwards, and then it went.
Yeah. Yeah. Okay. That makes sense then. Yeah, whether you do domain after, have it in the initial function definition, it's got to be there in some way, shape, or form. Or even if it isn't, you can just chuck in n values until you get an x that makes enough sense. Like you can see where the point is supposed to be. It's going to be somewhere between 50 and 55, just based on the graph. So even if you
Yeah.
do forget domain, you can still work it out from there. Okay, supporting rod connects to a point Q on the second bridge on arch 5. Oh, Q, there you go. Yeah, okay.
Perpendicular to the second bridge as shown in the diagram.
Find that distance. So basically this little section in the graph is what we're caring about. This will be how many lessons ago was this? This was maybe like a week ago. We did something similar.
Would I start with just finding the gradient of the perpendicular line?
Do you need gradient?
But I feel like that didn't really have much to do with it.
So it tells you perpendicular means, because if you want to find a distance, right, whether it's perpendicular or otherwise, you want to know the 2 points through which you're finding the distance and do your Pythag basically, or distance equation. And because it's perpendicular, it means you can either do a y equals mx plus c approach, where you do, your -1 over gradient of tangent to get the m part, and then sub in a point to get the plus c, or it tells you to do normal line off of that coordinate you just found of p. That gets you the equation. You then need to... Now the challenging bit there is you now need the equation of this line, the ramp looking thing. But you know what the gradient of that is. You know the y-intercept is 5.
That's fine.
Yeah. And so you just find the q off of that solve. You now have your 2 points. And you can go from there.
Okay. Almost there. Sorry for the wait.
Yeah, no, it's a long one. You gotta, geez, what are all the steps involved if we really think of it all? So we've already got P. You do normal line, then you find an equation of the slope thing, equate them together, they get Q, and then shove that result back into your slope equation, you get Y, and then distance equation. Yeah, there's like a million different steps to it, you're fine. I'm still doing it in the background, by the way.
Okay, I got distance as 1.91 meters.
Crushed it. Yeah, absolutely smashed it. 19% pass rate, by the way. So, congrats on
Yeah,
the
well,
top.
3 marks, 90 seconds per mark. That
Yeah.
took me about a good 5 minutes. So.
Has it been 5 minutes on it? Really? I wasn't exactly timing it, but
I think it took me about 4 or 5 minutes.
yeah. I mean, look, there's going to be questions that are time sinks, and there's going to be questions that
I
are
don't
time
know.
saves.
How do you do the normal line function? I
Oh,
did
sure.
because yeah, I kind of don't know those functions.
Yeah, okay. Oh, well, that would have definitely saved you heaps of time. It's in the same spot as tangent line. So,
No,
do you know what?
I saw it and then I just didn't know what to do when I saw it.
Oh, it works exactly the same as tangent line does. So you do function, comma, x, comma, where you want to do it.
Oh, okay, okay,
Yeah,
cool.
syntax is identical.
All right, cool.
Yeah. But yeah, well done. Very good.
It's satisfying though when you get it right after spending all the time.
Yeah, yeah,
It's kind of annoying when
precisely.
you get it wrong.
Mm. And yeah, like as I was going to say before, like there are going to be time sinks, there's going to be time saves. Like, part D was a time save, you saw that immediately, it's just tan. Um, Find the coordinates, that might have taken a little bit longer, but, not 2 marks worth of time, certainly not.
Yeah,
And so, yeah.
they give you reading time, right? So I guess like that's what
Yeah.
you use to like see which ones you're gonna spend a little longer on.
Yeah, I mean that's what last lesson was basically about. Like, how do I approach an exam? And we did a very brief reading time where I just sort of scrolled end to end which ones seemed like easiest to work on to hardest to work on. Some of them you can even answer off rip, but in a tech active, very unlikely you're going to be able to find one that you can immediately just know the answer, and then because it's usually calculator required. But yeah, so the format there is always 15 minutes reading time, both in the tech free and the tech active.
Right.
It's sort of a bit harder to plan your approach to tech active because there's so much more in it. Um, so it's more so just like digesting what's in there. You might suss out some multis if you want to crush some easy marks.
Right.
There's a bit of
Yeah.
a debate onto what's most effective, whether you save multis for last because you can at the very least knock them all out in a minute just by circling random numbers, or if it's better to do them at the start, or the easy ones at least, so you can get free marks as fast as possible.
Yeah.
I'm more on the side of the second there, which is get as many free marks as possible, builds your confidence, you know that you've completed X% of the test already, and so that's more or less where I'm at on that, but
Yeah.
you can go either way.
Just to give you a heads up,
Mm.
I'm gonna have to leave in 20 minutes because I gotta go training.
Yeah, no, that's fine. No worries.
Yeah. I was kind of because no one else is here.
Yeah,
Pia's not
yeah,
here.
you're good. You're good. But okay, so probability stuff. So, yeah.
Adults in two name accounts. Matt Slender and Stats are very nice names. Resting heart rates measured in beats per minute. Honestly, I'm not sure with the
Not sure.
probability.
Yeah, no, that's fair.
Usually I just let Pia take over here, but
Hmm. So, yeah, with the probability stuff, the first thing you want to do is determine what type of probability you have. Hopefully it was easy enough to
I
spot its normally
I know
distributed.
normal distribution is the one that's like it's like a high in the middle,
Yeah,
and then it like becomes smaller as you go to the sides.
yeah, you got like a little bell curve shape.
Yeah.
Absolutely. So once you spot that it's normal distribution in a tech active, you go to your distributions menu. It's the first three there: normal PDF, normal CDF, inverse normal. I've never seen a circumstance where you need to use the PDF. You're pretty much only ever using CDF and inverse normal. So
Right.
CDF is for calculating probabilities. If you want to know the probability from A to B, you use a CDF. Same thing with binomial, right?
Yeah.
Inverse normal is when you're doing effectively anything else, whether it's calculated an x coordinate, a z coordinate, mean, standard deviation. It's pretty much useful for all those sorts of things.
Right.
In this case, we're calculating
Me
probability.
and Ksenia are starting to do probability
Yeah.
because we basically finished with integration now.
Nice. Okay, so you're doing the these kinds of probabilities or the year 11 probability stuff?
Well, we haven't had our first lesson yet, but the plan is to probably just smash out the easy stuff pretty quickly, like
Yeah.
because in school I've already learned like conditional and whatnot and independent numerics. It's mainly just like this 3-4 stuff, like the distributions.
Yeah. Yeah. Okay. So it will be similar. So even with 3-4, it does start out like you're talking about, which the probability fundamentals, then discrete, then binomial. It's only that year 11 will stop at binomial, and then that's your probability thing. Versus year 12, you're then going into continuous probability, normal distribution, and sampling and estimation.
Yeah.
But okay, so in this case, we're trying to find a probability. It says find the probability. So that's your hint that the CDF is going to be the important bit here. And even just looking at the entries that are in the fields there, you need a lower bound and upper bound at the mean and standard deviation. Maybe I'll throw it back to you here. What do you think we want to plug in?
Lower bound 60.
Mm-hmm.
Upper bound 90.
Yep.
Does that next symbol mean standard deviation?
Standard deviation is the bottom one. Mean is
Okay.
the mu.
All right, okay. So 68 as the mean,
Yep.
then 8 as a standard deviation,
Brilliant. Done
and
deal.
like 0.838
Yeah, 838 there.
yeah,
Yeah.
0.38.
Yeah, precisely. So they're not so bad. You just got to figure out, okay, it's normal distribution, solving a probability, therefore CDF.
Yeah.
So it's also just getting your head around the concepts. There's a lot of them in probability, and they overlap quite a bit. Because, statement like find the probability, it could be a binomial CDF, could be binomial PDF, could be a normal CDF, could be the piecewise function integrals. There's a lot of different things that come up.
Yeah.
Oh yeah, speaking of conditional probability, part BI's got it. Find probability of H given S.
Yeah. The probability of the intersection over the probability of S.
Yes.
We can already fill what we know,
Yeah.
which is that 0.29 will be the bottom.
0.29 will be the bottom. Let me just double check that. 0.29 is sport regularly. S is sport regularly, yes. So 0.29 is going to be the bottom.
9% adults play sport regularly and have a slow heart rate. So 0.09 is going to be our top.
Mm-hmm. Yeah, crushed it.
0.09 divided by 0.29. Should get 0.310.
0.310. Yeah. Very good. Nice. Here you go. You said you finished up independent recently. Are they independent?
Let's see. No.
Yeah.
But if it was independent, then the probability of someone having a slow heart rate would be the same as a conditional. So, but it's not. So.
Well, hang on. So it would be oh no, yeah, you're right. Slow heart rate because it's
Or
H.
you could multiply. You could be able to like multiply 0.1587 with 0.29, and it would be equal to 0.09. But that's also not going to happen.
Yeah. Yeah. There's that. The whole independence is probability of one thing times probability of the other thing. The intersection becomes the product. Yeah. Easy done. Part C.
Random sample of 16 masculine adults will contain exactly 1% of slow heart rate.
So I might get a bit trickier because it's unit 3-4 probability.
Yeah, I'm not too sure. I don't know if you could use a tree diagram, please, because not. I feel like there's probably some as because it's.
I mean, you probably could, but I wouldn't want to draw 16 branches or stages worth of tree diagrams.
Oh wait, hold up. Okay, let me just open up the exam on my end real quick.
Yep.
Would it just be like the probability of someone having a slow heart rate, and then like to the power of 16? Oh no, but we're trying to find one.
Yeah, and not just one, but yeah, exactly one.
Exactly.
So bit tougher. So I guess the first thing you're understanding is the probabilities change. It's not just any given person having a slow heart rate. It's 1 out of 16 having a slow heart rate. And so what
Right.
that does is it puts it into discrete now specifically, rather than the normal distribution and continuous. I think maybe a good way to recognize the differences there is as soon as you have like a sample size or a group of things and you're trying to find a number within a group, it's going to be some form of discrete. The good news is discrete, even though it has three topics, which is regular discrete, binomial, and sampling and estimation, there's still only really two ways of solving it. It's either binomial or it's discrete, because sampling and estimation often gets back to binomial ways of solving things. And so what we do from here now is say, okay, sample size 16, so that's our n, exactly one person, so that's x equals 1, and the probability of slow heart rate, well, I'm assuming we have that somewhere.
That's the
Yeah, it's up here.
the hard rate's up there.
Yeah, so probability of slow heart rate is 0.1587. So that's our p value. So when we go through and do our binomial, so it's binomial PDF. PDF is for one specific value. CDF is for a range. Child, as we said, so that was, I think it was 16, right? Yeah. P value 0.1587. And x value was 1 because you wanted exactly one person with a slow heart rate. And that'll give you a probability. Cool.
Yeah, I'm just gonna try that real quick. 16.1587 and then 1.
Mhm.
Yeah, cool.
Yeah, so some people will actually just ignore PDFs in general and do exclusively CDFs. If you want to do that, that's fine. All you got to do is make sure you make your lower bound and upper bound the same number. That'll also work. So if you want to cut out a function for whatever reason, you can do that. Otherwise, maybe another tip would be if you leave off that x equals 1, what you'll actually get is an array of all the outcomes. So you'll have your x equals 0 at the very beginning, your x equals 1 at the next spot, x equals 2, so on and so forth.
Okay.
So if you're solving, I think we did it before, which was like you had like a table of outcomes. If you've got to do a lot of them, then you might just want to belt that one out and then just write down whatever comes out.
Okay.
Okay, that's that one. Double I, very similar. Random samples of 16 adults. P hat is proportion of slow heart rate. Find probability of P hat being greater than 10%. This is a trick here. I'll let you have a stab first, just in case.
Find the probability that there is more than 1.6 people with a slow heart.
Great. Yeah. So you found it already. Just flip your proportion to a discrete equivalent, and then exactly the same method that you've just done.
Right. Let me try that.
Yeah, go for it.
So would our probability, like, the success part still be the same? Or
Yeah, because we're still talking about slow heart rate.
but then our X value becomes 1.6, right?
So worth pointing out, it's now greater than 1.6. So you're going to have two x values, an upper and a lower. But yes, you would put 1.6 as your lower, or you can put 2, and you can round it yourself. Either way, the CAS will give you the same answer. It'll do the rounding for you if you don't, so you should be fine either way. You only really run into issue if it was like greater than, I don't know, let's say, so greater than like 1/16. Then you'd have to do the rounding manually because greater than 1/16, x equals 1. You want to make sure what you're putting in the lower and upper bound is the inclusive, not the exclusive.
Right. Is it 0.269?
0.269. That came a bit off. Did you do... What was your upper bound?
Upper bound. Is upper bound the one that you put first?
Lower bound is first, but that shouldn't matter.
Upper bound was 2.
Oh, wait, hang on. Did you use a PDF again?
Nah, you CDF.
Okay, CDF. Cool. So you got number of trials, which is 16. You've got probability of success, which is the same thing as before, 0.1587. Lower bound 1.6 or 2, either way. And upper bound 16. Okay, so you probably just didn't have upper bound 16, because there's anything greater than or equal to 2 there.
Yeah, I had upper bound as 2. My bad.
Yeah, no, all good. I guess that was actually kind of my fault, because I said about the CDF, you just do upper and lower the same. That's only if you want to use it as a PDF. So I put that seed in your head. My bad. But yeah, that's that one. And then triple I. Very specific way we solved that. One of the tricks you already know.
Converting to discrete.
Yeah, converting to discrete, absolutely. So the equivalent X statement would therefore be something.
So find the lowest value for n, for which everyone in your sample has a slow heart rate.
Greater than 1 over n, so you're exclusive of the 1 over n.
No, I'm not too sure.
Not too sure? Okay. Well, the first thing would be, like you said, to convert to discrete. So how about that? Can you convert that to an equivalent x?
No, I'm not sure.
Okay, that's fine.
It just looks like
So,
the reciprocal of the sample size on one end, and then
reciprocal of it? Yes, so something very similar, right? Which is p hat's just x on n, effectively. So if we don't know what n is, that's still fine. Whatever's on top is effectively just your x. So 1 over n, if I had 1 over 16 instead of 1 over n, you'd be able to quickly figure out, oh, that's just one person. Versus if I have 1 over n, well, the only thing that's different there is I don't actually know what my n is, but it still ends up being one person, simply because it's 1 over your total. So the equivalent is to say, I want to do a CDF from 1 to n, whatever n is, all the way up with the probability that we had before, until we get a number that's just above 0.99. Right, we want to find the least smallest value of n that'll get us above 0.99. Fair enough on the approach, or what we're going to try and do?
yeah.
A couple ways you can do this. Just guess and check it. It's the best way of going about it. Your first mark's going to come from converting p hat to x. Right, that's where you're going to get your first mark out of the 2 marks. So you can, in fact, then use a guess and check approach there. I didn't check the answers ahead of time, so I'm just going to pick random numbers. So let's say n being 10, for instance. Let's see what we get. In fact, let me just double check that's the right p-value still. 0.1587, yep. Cool. So we test 10, that's 0.82. Seems a bit small. Let's knock them up by 5 higher. 0.92, still small. Maybe we'll even go up by 10. Even further. Let's try 30s. It's very quick to hone in on the number you're looking for. Maybe walk it back to 28. And you're kind of doing a bisection method, almost, to get there. Where you're slowly shrinking the interval of the jumps that you're making. 27 looks like the number we should be using, but let's just be absolutely sure. Yeah, so 26 would be below 0.99, 27 gets us above 0.99. And so, yeah. Why isn't that? Oh, I see what I've done wrong. Uh, I forgot my other tip, which was make sure that what's in the brackets is the inclusive, not the exclusive. This was greater than 1 over n, not inclusive, so we should have actually had a 2 here. Whoops. But it's the same idea, just with maybe now a bigger sample size. So if we go 35, that's close. Let's try 37. 39. That's probably it. You could obviously try the one back, but now I'm just sort of bashing out numbers. Yeah, 39 ended up being the right one there.
Right.
So that'd be the best way of going about it, presuming you can obviously chuck in the right numbers and don't make the mistake I did. The other thing you can do is a complement probability approach. So if we have a look at the screen share again on the exam report, what you can do is say, okay, probability x being greater than 1, that's the same thing as x being greater than or equal to 2. Now what you can now do is flip that. 1 minus x equals 0 and x equals 1. You're just going backwards in the other direction. And both of those are Bernoulli sequences. So you can expand those out into their Bernoulli sequences and then CAS solve an equation rather than guess and check your way through everything. This probably just takes longer, I'd say. You do get your immediate answer, then you have to try and round it the right way. But it's probably slower, in my opinion, to belt all that out. There you go, 8% pass rate. I wonder... Actually, no, I reckon, yeah, 6% would have been to get that first mark, so the vast majority of people just flat out don't know how to do this. And then I reckon...
Chris, sorry to interrupt
You gotta go?
you. Yeah, I gotta go.
Yeah, easy. No worries. Take care, mate.
Thanks for today.
No worries.